Okay, all right. So I'll just get started. Welcome everyone to today's community hangout. As you know, George, sadly enough, is quite sick, so I wish you all the best, George. He's still around to record, so thank you for that. And today we have Marta with us. I don't think Marta needs an introduction, but if you want to, please go ahead.
Oh yeah. Well, I've been working at Dusk for some years now. I've been for quite some time working and actually leading the research team, and we work on the privacy aspects of Dusk Layer 1, Dusk.js. And yeah, just recently I started collaborating with the DuskEVM project, and yeah, I think I haven't been in touch with the community for some time now, so I'm excited to be back, I guess. Yeah,
exactly. And I think they're really willing to hear what you have to say. I think there was a lot of requests actually for you to have a chat on here. So really cool. So about this project lead part of DuskEVM, I've got a question about that. I'll just throw it directly at you. Why did you become the project lead for DuskEVM, and what is your role and your main activities here?
I don't know if that's 100% a question for me. Maybe the person who asked me to do it, but
I don't know who that was. So
I think because I started first as a researcher, and I was very much like in my own box every time, like working with the specific primitives, trying to improve very specific parts of the protocol. And I think as time passed by, I started having this overall view of the whole project. And I think while leading research, I also learned how to manage a team and a project that's very big with different parts, and also getting comfortable with more the management of a big project rather than going into like small details, which was maybe a little bit my role at the beginning. So I think that because of that, at that time you were the one leading the project, but you were also like very involved in the technical side. And I think that as a project lead, sometimes you also need to keep this ability of stepping back a little bit and see how the big pieces connect together and make like a plan for the project to succeed. And I think at that point that figure was a bit missing, because everyone was you all had like a lot of work and a lot of things on your plate. So I think I could bring that to the table. It's true that it's all the components are pieces I'm less familiar with. Like, for example, for research, although I didn't know the exact details, most of the pieces I was very familiar with. So it's also been like a bit of a challenge for me to feel comfortable with a technology I'm not maybe as familiar. But still, I'm like very happy with the role, to be honest, and also the team, because everyone knows very well their own expertise and they can bring what they know the best. So I'm trying like to help as much as I can, and also bring this like general view to everyone in the team. So yeah, I guess that answers it, but I don't know if you want to complement my answer, given that you were involved in the decision.
I mean, it's a good answer. I mean, like I wrote before in the chat, right? The scope of the project in who does what has changed over time, right? So the involvement of our team has increased a lot, and you've always been someone on our side that's really structured and very active in like project board management, right? I think we both share that the trait, but of course I cannot do everything, right? And we have two very large projects, a lot of external communication, a lot of knowledge that needs to be shared, and a quite nice roadmap ahead for DuskEVM and the evolution of a modular blockchain stack, right? And it just doesn't make sense that is on my plate alone, right? We have very capable people in our team that can help make sure that each of these projects get the attention that it deserves. So I think you made the most sense to do that, and I'm pretty sure it's in very capable hands there. So it's a perfect match, also for the time that we're in as a company, right? So And in terms of activities, what would you say is your main activity leading DuskEVM?
Sorry, Han, I think you dropped for a moment, or maybe it was only me. Can you repeat the question?
Yeah, sure. What is your main activity in this role, or your main activities?
I would say, to be honest, it's mainly keeping track of all the components, how they are being built, and think.
Oh, I think it's actually Marta dropping.
Which will be the. Okay. Which will be the next steps and who's going to be able to work on what and how all these pieces are going to fit together. So I think on the one hand, it's like keeping track that everything's going as they should, but at the same time, be a little bit ahead of what it's coming. So.
Marta, I think you're dropping from time to time.
Okay. I thought it was you.
It could also be. I don't know if someone.
Yeah, if it happens again, let me know. Maybe I can. Oh, Marta's hanging. It's me. Okay.
Yep.
Okay, if it happens again, maybe I can reconnect. Let me know.
Yeah. All right. Okay, let's go to the next question. Beyond the RWA domain, what unique and exciting use cases do you see being enabled by DuskEVM special features that ordinary EVM chains do not provide?
Yeah, I think on the one hand, one thing that is cool is that we use quite a standard technology, so almost anything that can be built in EVM can actually be on our site. So I think that makes it particularly easy, for example, to talk to other projects, and also even to bring technology that it's on Ethereum, it in our side. And I think we bring especially two things on the table. The one is that the layer one is different, so we gain all the features from DuskEVM, so all the privacy features and the fact that it has a different it has different properties than Ethereum. And on the other hand, I think that because we are very focused on real world assets, so we take into account all the regulatory environment and all the privacy that it's needed, and we really take into account all the legal framework, let's say. I think that we bring this into the table, and I think that many things that are developed on layer 2s and on other layer 2s, they have to do that on their own. And I think in our case, we also help we help already the projects go in that direction. So I think Dusk especially brings these two projects. We already provide a framework that it's friendly with those environments. I would say that's the main difference.
Yeah, all right. And which one of the advantages or use cases do you see as most interesting happening on DuskEVM? I mean, you have an interest in privacy technology, right? But we also have the regulatory side on our own side.
Yeah, I think that for me, I would say, to be honest, tokenization of assets in general, that's something that we've been working on for quite some time. So I would personally, that's something I would really like to see soon live in our infrastructure. That would be for me the most exciting project, because that's something that we thought about for a really long time. And I think there is a place where you need to keep this trade-off between privacy and compliance. And I think that's bringing this extra layer of privacy in some use cases. In the case of tokenization of assets, that's something that I think we can do, and we've worked on for some time. So I would really like to see that live soon.
Yeah, exactly. So it's the combination of everything we've done before, and then bringing that to an EVM environment as well, where you see the extra tokenization, and then, for example, seeing a Hedger extension to what we've been building in the meantime. Yeah, exactly. Cool. Yeah, I think one of the things when it's just from a technical point of view that I'm looking forward for is seeing how we can evolve differently from the existing ecosystem out there, right? For example, Optimism is taking a certain path, Ethereum is taking a certain path, and we have taken some of the technology that they've done and merged it together with ours, and then seeing how we can evolve again beyond that, right? So for example, the fast finality features that we're thinking about that make us more compliant is something that I'm also looking forward to how that will work out.
Oh, sorry.
Soon
Okay.
coming.
Sorry, I think it dropped again. Could you repeat the question? Sorry.
Oh, no, I was saying that this was my add-on on that. I'm looking forward to seeing how we evolve the ecosystem ourselves, right? Beyond what the others are doing, for example, with the fast finality features. And that's...
Yeah, I completely agree. And I think we also, it's a project that has developed, at least since I joined, we've also developed a lot. We have evolved a lot, sorry, I meant. And I think, at least from the different pieces I was working on, one of the main aspects that made it change was the changes in the law or the regulations. So that made us adapt a little bit where we're going and so on. So I think that now that we are already in touch with use cases that are going to be built, we really see the reality of this. So I'm also very excited where this brings us and how we evolve as a project.
Yeah, I think regulatory side is also quite interesting, right? Because then on one side we've seen regulations where we had to change things, right? For example, with on the L1 with Phoenix, and on the other side you see regulations actually becoming less stringent. So the implementations of the RWA side is becoming less of a pain, right? For example, with the DLTR, when you get the exemptions, you can basically ignore certain laws. So it's quite interesting to see how we are diverging on this middle ground.
Yeah, I agree. Still, I think that all the work that it's done has actually helped us build other things later, because we already have the previous experience. So yeah,
definitely. Yeah. Okay, so so someone asked, as an extension of the question I asked before, in other words, what novel applications could realistically be built on DuskEVM that would not be feasible on a standard EVM?
Yeah, I mean, I think it's more or less what I said already. It's not that you cannot build them on an EVM, but I think our DuskEVM projects are going to have more support in terms of which kind of applications they want to develop, if they also need a little bit of guidance in the space. I think that's something that we can bring. But on the other hand, the main difference is if they bridge to the layer one has features that Ethereum does not have. For example, you can use Phoenix. So there's this transition to a layer one that can be private, and that's something that's a big difference. So if you want to, for example, have confidential transactions in this EVM, then you can start with the layer one and then use Phoenix for that. Use the bridge to the layer two and so on. So I think that the privacy on the layer one, it's a feature that's different from other Ethereum compatible chains. That's the main difference, I'd say.
Yeah, and that also is maybe worth reiterating that everything that is on the L1 can still work, right? It can still be built on top of, can still be used in the way that we originally envisioned. On the other side, the DuskEVM can also have certain extensions that we can apply based on our knowledge, what we did on the L1, right? So we already have been working on privacy features on top of the DuskEVM. So these two work in a way synergetically with each other, right? The knowledge that we have can be
Yes.
applied both back and forth. And even the L1, we've been improving it as we went along to integrate DuskEVM, which means that for developers, it's also easier to develop on the L1 again. But the power of DuskEVM is really in its composability and API equivalence for everyone that's integrating, which is quite important, as we've seen.
Yeah, actually,
the last
I
2
think
years.
that for me, the most interesting is not only what you can bring uniquely in DuskEVM and not in an EVM, is actually the other way around. Like, we already have Dusk, which is unique, and now you have this whole lot of use cases that can typically be developed in an EVM. So the fact that it can be on top of Dusk, like, I think that's what brings on the table. Like, all of a sudden, like, you have like all this set of projects that can immediately be developed here. So it's yeah, and it's compatible. Like, they don't need to make changes. So yeah.
Yeah, what Duskino wrote, I think it's quite astute. He says the beauty of DuskEVM isn't that you can do something unique with it; it's the fact that you can use it like you can use ETH, and that's where the most knowledge and experience already is in the market. And that's really really true. Also in terms of tooling and whatnot. So I think this type of extension is really powerful for us. Okay, let's see. Then there's also a question about technical differences between the two, but I think you already answered that. Then there's a question around the launch marketing. Someone writes, last time we had Dusk paying random Twitter handles, termed KOLs to put out tweets, which certainly left a poor taste in mouths. Okay, that's a strong opinion. This is a proper L1 and probably first of its kind. Are we going to see something befitting of that notion? So we don't have a situation where it feels like we're begging to be noticed. You've seen that this space is filled with lots of trash, which is really true. And even if a project's a substance, if they don't blow their horn appropriately, no one notices. Stuff like reaching out to MetaMask team or Phantom team for something for market exposure. Yeah, I can take that one partially if you want, Marta. You can also do it. It's up to you, but... No,
I think it's better if you're probably more knowledgeable. Like, usually my experience in research, you don't make a lot of marketing around boring theoretical advances. So
maybe we should do some research on marketing ones, but no. But I think that this is one of those things where you have a plan, right? A fully rounded plan, and then if you have the plan in place, you actually execute on it, right? So I think with the mainnet launch, there were some things that went wrong in that regard. We've definitely learned from that. And we're definitely doing things differently. One of the things that I always try to push heavily for when we're dealing with external partners is, in part of the deal, we also sign marketing agreements, right? There's like subsections where we talk about what we're going to do in terms of marketing together. And so what I always want to see is that when we have an agreement that for the marketing part, we do co-hosted spaces. And so that if there's a project that's much larger than us, that we are then, from a marketing point of view, using their marketing resources as well as having our own people, our own community participate. So that's one of the things that we do, and there are many more things. So all of this is in the works. I think that it's not only pay to play that is relevant here. Although pay to play is quite a big factor in crypto, and a lot of insider VC backroom deals are what causes a lot of stir in the market. I think it's also really important that we start finding product market fit, right? So that we find that we build the products that users want, and that users then start promoting those. So if we have just a network, we release it, and there's no good product to use, then you can market it all you want, but that's not going to lead to anything. So having a good product, a product that people want to use, a product that people like, is just as key as doing any sort of pay-to-play marketing plays. I would even say it's much more important, but opinions differ here. So we're trying to attack every vector there. And then secondly, what is the plan for attracting third-party developers quickly on DuskEVM? I think that with our reputation in the crypto space from non-community side, right? So if you're just talking about other projects that are out there, we are an established party, right? We've been around for 7 years. Usually that means something. We haven't had any big controversies that have really damaged our reputation externally, right? That's this type of provenance and the fact that we're dealing with the regulated entities really helps a lot in communication with third parties. And we've seen a lot more interest in wanting to deploy things on DuskEVM from bigger parties than I would have expected. So I'm not saying it's a large amount of numbers, but the partnerships that we're really focusing on, the partnerships that we consider strategic partnerships, there are bigger names attached there than I would have suspected initially would agree to it, and we can see that in the type of cost pictures we get for this as well. They're really good. So yeah, I really hope that that this will at least kickstart something, because we are building a quite beautiful ecosystem, I must say.
Yeah, actually, I would like to add to that it's true that sometimes with just marketing, it's difficult to even like us that have the knowledge to really discern like if this is like a legit project or not. But I think in our case, we're in a stage where when you see serious companies, like we have regulated entities that are on board and we have conversations with them, and once you have trusted entities that are using your technology, I think that already is selling by itself, like a fact that it's a product that it's serious and it's working and people have trust in it. So I think in our case, we're in a stage where apart from marketing, I think the reality will already tell a lot about the project. So yeah.
Yeah, and I think especially stocks will be a very key application in that regard, right? Because in the end, DuskEVM is again just a piece of infrastructure, right, to enable what we want to do afterwards. And stocks is the logical conclusion of that, right? Especially when we consider that that this will be the first iteration of what we'll do with the DLTR, right? So yeah. Agree. This is a fun question. How many days, weeks ahead of launch will you be announcing the launch date? I guess for us, that's not something we can answer, right? In the end, this is something for marketing to decide. We as tech, right, we will just say, okay, technically we're done now. It's working as expected, and then we'll leave it in the capable hands of marketing to deal with that. Also because of the fact that we're dealing with external parties, right? And they need to test stuff, they need to deploy stuff, and if they want to be a launch partner that's active on day one, we do not per se recommend everyone to do that. But when that happens, then you need to account for that in your timelines as well.
Yeah, and I think in general, because I know like from the community and also and in general, like everyone wants to see everything done as soon as possible, but you always need to take into account like, okay, you need some time to develop, then you need some time to properly test, and especially integration tests in this particular project where there are so many pieces together that they work alone, but then when you add them like all together, you need to make sure that everything works properly. And I think you also need some time to proper test everything so that you make sure that when the launch, everything is gonna go as expected. So yeah, I mean, we cannot really answer how many days or weeks in advance we will be able to do it, but we will announce it. But everyone is very excited about delivering as soon as possible and make sure that everything is launched working. So yeah.
It's basically for us at tech, it's like we're ticking off boxes, right? Okay, this works as expected, this works as expected.
Yes.
I think this leads into a nice follow-up question about what has been the biggest because you're talking about integration testing. What has been the biggest challenge in building DuskEVM?
Well, actually, you've been in the team for a longer time following the project, so probably you can answer. For me, when I came in, I would say that actually it's integration the biggest challenge. Making sure that all the pieces fit together. And I think that's it. Because when you are working on your special, like on your own box, you think that's going to be it, and then you realize, maybe you need like this extra piece to, like connect these two components. So you need to develop this extra piece of software or like, so I think that when you integrate everything is not only that you realize if it's working or not, but maybe something is missing that will make the connection work. So I think that with projects like this, that's my impression of what was the biggest challenge, but maybe you have like more insight, Hein, like you can, if you have a different answer.
No, I think that is indeed true. I think there's two factors I would say that are indeed a thing here. It's like you said, the integration side, because when we started out, we did an analysis. I did an initial iteration, then Thomas built on top of it, and this was a project plan where we scoped out how everything would look like, and we had an analysis part in that as well. But then when you start implementing things, you still notice that there are slight differences, right? Like API differences that crop up, or behavioral differences, because Dusk and Ethereum in a way are very similar, but also very different, very different. So it's you have the same concepts in place, but the way the concepts end up being available are very different. And those things are quite difficult to debug and rectify. On the other side, and I think that this also leads into the other one, is context, right? Like contextual awareness of how everything works. We have our own world that we've been working in for the last 7 years, right? Our own blockchain, our own technology stack, and our own APIs. And so when you get to Ethereum, then it's different, and you need to learn these minute details, right, about how does finality impact certain aspects of when you try to connect with each other, or how do the APIs look like. And I think that the learning curve there is one thing that was to consider, can be considered a difficulty or a challenge, right? And this is a known challenge, so it's not surprising. We had a lot of documentation that we had available to go through, but I think that was a challenge, and indeed the integration side.
Yeah, if I may add, I think it always amazes me, because when you look at the project like from a high level point of view, everything seems so obvious and clear, like how to make it. Okay, you translate this to this, and then you connect these two pieces, and that's it. And then you find the difficulties and how it becomes in the project with these small differences. Like in these details is where you actually spend like most of the time. You didn't realize how big of an effect this would have. And not only in this project, but for example, I remember when we were working on Zedger that we made like the specifications, and then when you started implementing, it's like, we assumed, I don't know, like the output of this function was living in this certain field, and then it turns out the input of this other function needed to live in another field, something like that. And making this translation wasn't as easy. And actually, like, it's in these details that and when you start implementing them, that's when you realize like how important it is to have the knowledge, and also like to develop all of these, and how long it takes. So yeah, apart from integration, all these nuances, like learning all these small details, is what makes the project it is.
Yeah, Pareto principle, right? Like 20% of the things will take 80% of your time.
Yes.
It's always the case. Okay. Someone asks, can you give us a high-level overview of the remaining tasks before the official launch?
I think, first is all the... apart than completing like a small tasks, it will mainly come testing phase. That's going to be super important. Like right now we're testing on DevNet, but we need to test it on testnet before launching on mainnet. Having like internal security reviews for some of the contracts, and finalizing like the binaries, making sure integration works, work on documentation. Those are the main tasks, I think. Yeah, then we're missing something. But
No, I think that covers it nicely. I think that's at the moment we're mostly debugging and seeing if there are misbehaviors, right?
yes.
Maybe there is still some front-end work we're doing, but this is happening in parallel, and we're quite far with that as well. So last week, for example, at the beginning of this week, Kieran and I, for example, set up the connection with DuskEVM on the web wallet for bridging. He's building a new bridging interface for that, and all of the connections there are in place. So it's looking quite nice, but yeah.
Yeah, actually, we had a meeting with the whole team, and I think it was good to realign where everything sits. But it actually looked very, very nice.
Yep. Relative to what you probably thought.
Yes, I was very pessimistic.
So someone asked, will all components that enable L2 DuskEVM Hedger be open source before launch, or do you plan to keep some parts private initially for tactical reasons?
Actually, do you have an answer, Hein?
Do I have an answer to that? There will be parts that we will keep private for now. Especially on the Hedger side, right? Hedger is IP, I would say.
Sorry, it was not only DuskEVM, it's also Hedger and okay.
Yeah, DuskEVM and Hedger, right? So that's IP. DuskEVM, I would say that the current implementation is not that interesting, right? It's a translation service that we're looking at some point to move into Rust most likely. Then parts will be open source. And we'll slowly start making more parts of this available, because we have a roadmap that goes from what we currently call the MVP, so it's like the minimal viable product that we can launch with, towards fast finality, where fast finality will be integrated into Dusk DS itself, to decentralization, in which, at some point we basically can open everything up. We didn't make any modifications to Optimism itself. So this whole node side, you can just take the binaries there, and if you connect to our translation layer, it should work, right? So that's not a problem at all. The translation layer itself is at the moment closed source. But at some point that will not be the case anymore.
Yeah, I think
as a side effect.
Yeah, and for Hedger right now is closed source, not because of anything, but I think, most of us we want to deliver things that look nice. So Hedger was at the point where we have the MVP, but we still wanted to clean some things and make it available once it's in a shape. So I guess it's actually similar to the DuskEVM, that right now we're going to have some pieces, but the idea is to deliver everything open source. But yeah, we just probably need to work a little bit better on documentation of the code and improve some small pieces. But at least on long term, everything should be open source, and I think that's been the policy from day one. So nothing has changed. The fact that you see closed source, it doesn't mean we intend to keep it like this. But sometimes when things are ongoing and on progress, sometimes it's okay to just do it privately.
Yeah, exactly. And I think that one of the things also that's nice about open sourcing DuskEVM is that others could run instances if they wanted. For us, it doesn't really matter a whole lot. Though, is there a question about, we saw the GitHub commit that could lead to a testnet push for EVM. Is that something you could say something about? So I think they're talking about the DuskEVM Genesis repo here. This is basically a repository that contains the details on how our chain is launched, the configuration for it. And this is not something very meaningful. Before, this was available through Lumos, the third party that we work with, but we've taken full control over everything now. So I've moved it in our own repositories, and basically these are just used to start up a new instance or reset an existing state. So this Genesis will probably be updated a couple of times more. We'll add a testnet one and mainnet one eventually, and maybe we'll put it on a different location as well, something like IPFS, but it doesn't really matter. These are just configurations, but they're quite useful for setting up a network, a must. So that are most of the questions that we had. General questions. I do have a couple ones that are more specific, Marta, for you. I think you'll like some of these. How does Dusk plan to handle a critical case of circuit level bug? Is there a governance or cryptographic safeguard beyond a hard fork, including ways to audit or detect past exploit in Phoenix transactions?
Yeah, that's something that we thought a lot while working on Phoenix, and it really depends on the exploit. I think depending on the bug or the potential problem, we may not be able to detect it. But in some cases we do. Like, for example, if it has to do with the security assumptions, we can deal with that. In terms of circuits, you always have this risk, but it's true that Phoenix has been reviewed by many people. It has been audited and it has been live for quite some time now. So we would be quite surprised if that would happen. But of course, things happen. We've seen it in other projects as well. But one of the things that happened, especially snarks, it's, for example, for the trusted setup is that you need to write like a whole new circuit, make a whole new ceremony and all these kind of things. In our case, it would just mean changing the circuit. We couldn't even use the same trusted setup, so it would only impact like the circuit implementation. And I think as everything that goes through the consensus, so like we would propose an update that would fix this bug, and then all the network would have, or a majority of the network would have to upgrade in order to implement it. I think these kind of things we cannot really be prepared for, in the sense that, okay, things can always happen. So what we did is we made like a list of potential things that can happen. Like, for example, if there are problems with the elliptic curves that we use or the specific protocols that we use, like the things that we have control over, like a little bit of list of cases of things that we know that can go bad. Some others we have no control. That's what I was saying at the beginning. Like, okay, if there's something that happens that really didn't think of, like, okay, you can not control that. But for those that we can control, we made sort of a plan on how to change all these components. And I think that's why it's important that in general the things that we build are as modular as possible. So if there's a problem with one of the components or one of the pieces, you can change it, you can replace it. So we have sort of a contingent plan, but I would be probably quite surprised to see if a bug was exploited. But you never know.
We also formally verified the protocol, right?
Yeah, there's a security analysis of Phoenix. You can find it in the Phoenix repository, and it's a formal analysis that proves all the properties and guarantees of the protocol. It's very, I would say, like heavy to read. It's like very academic, but it was done like by former colleagues, and you can read it if you're interested. But I think from our side, I think we did a lot, which was, okay, we published like the protocol, we did the security analysis, we had the code review, we had the everything audited. So of course shit can happen, but I think in that sense we try to minimize the risk as much as possible. So hopefully.
Fingers crossed, right? And you said the upgrade. So you said we can change the circuit. Is the change of circuit is that something that can be done as a drop-in, or is that something that requires a pathway change in Rust itself? I think it does, but
I think it requires a change in Rust itself. Yeah, because it's part of the. Yeah, I mean it's the logic of the acceptance of transactions, so you would have to change that. Yeah.
And you also have a gradation in what can happen, right? Like the worst case scenario is probably that someone can mint infinite amount of
Yes.
Dusk, right? And on the other side, you have situations that could be problematic if someone can steal nodes or whatever, right? But all of these things, in essence, in theory, you could, in worst case scenarios, you could always roll back the chain and then apply on the block after the rollback the changes you want, right? And then if the majority agrees with that, you can basically ignore everything that happened afterwards. So in case of an endless mint, that would be detectable if someone bridges out of Phoenix, and stealing of funds would also be detectable, right? So there's a lot we can do in theory when things really go to a way that we.
Yeah, I think the worst case scenario is this: like when you don't know if a bug was exploited. That's the worst scenario, because you really cannot detect what happened. When you detect it, yeah, you can roll back if majority. And it's not only on the security side, like if someone steals funds from others, but it's also on the privacy side. Like maybe nothing like. What do you say? Like there was no problem in terms of the security of the tokens, but for example, some data was exposed. That's also something a bit problematic. You can not really roll it back, like that's going to be public, but it affects differently. So there are different type of scenarios that we may face, and I think one of the. We especially thought of these cases because of the post-quantum questions that have actually popped up in some other AMAs. And most of the protocols that we use are based on problems that could be solved with a powerful quantum computer. So that's when we started thinking, what about if we transition some of these protocols into post-quantum protocols? And that's when we started thinking about the different primitives that we use, what would imply to change them, and so on. So, in the case of post-quantum, it would not only be us, but it will actually be a big part of the crypto space that would need to reassess what to do. But yeah, that's really where some of the questions came up in the team.
Yeah, I think that quantum proof algorithms is a nice one to move to. But I want to say, as an addition, that since we use DuskEVM, right, and EVM is optimism based, if they do any sort of quantum proofing, we can also gain that for free. So that's nice, and we can learn from their research to apply to our own L1 as well, right? There is a question here that goes into this that's worth throwing at you. What is the state of the quantum proof algorithms in general? What is planned to be implemented in Dusk?
For quantum proof algorithms, it's not my field of expertise. Maybe to give a little bit of context, essentially when we analyze if a protocol is safe or not, at the end it reduces to a set of assumptions. And usually these assumptions look like, okay, this protocol is secure as long as this problem is difficult to solve. And what does it mean difficult to solve? You need to say which kind of resources you have. So one of the classical problems is the discrete logarithm problem, and that problem is solvable in a powerful quantum computer. So protocols that we say are post-quantum, I don't know if it's the best word, but at least are not proven to be post-quantum unsafe, let's say. So those protocols are based on things that are different. So for example, lattices, hash functions, code theory, and that's like a complete different set of assumptions and techniques. So in general, I would say the cryptographers that know from one side may know not from the other, and so on. So I'm more like on the side of the discrete log and all this kind of protocol, discrete log based problems. And yeah, the post-quantum world, uses like complete different techniques and protocols. But I think right now, NIST was standardizing some protocols. I think slowly they are gaining like a lot of attention and they are being used, I think, in some protocols, but the adoption is quite slow because I think they are still not competitive to what we have on the classical models. And
Sorry,
yeah,
you mean,
I would say like, what?
So you mean competitive in what sense?
In terms of, for example, for proofs specifically, the size of the proof is way bigger. And also, I think computation time, well, it depends a bit on the size of the circuit, but for the prover side, I think it's also more efficient on snarks. But yeah, I mean, it's always like a little bit of a trade-off. But what I've seen sometimes is that some projects use some parts which are post-quantum and some others which are not. And the fact that you use pieces which are not doesn't make you post-quantum. So if you use your proof system and it's post-quantum, that's okay. But if your keys are regular keys that are based on the discrete logarithm problem, this means that you are not post-quantum secure because your keys are based on the discrete logarithm. So sometimes what I see is projects that try to introduce pieces which are post-quantum, but not the whole stack. So unless your whole stack is post-quantum, or you use post-quantum everywhere, you cannot really claim that your project is. So yeah, I see some project that... Yeah.
I mean, it's nice, right, that you can that your proofs are secure, that no one can fake proofs. But then if you can basically steal everyone's keys, then
exactly. So I've seen these, and sometimes I'm a bit like, but I mean, still, I think it's very nice that we try to like integrate all these products. All these protocols like slowly and keep like changing the pieces, and that's a transition at some point we and everyone should make. But yeah, right now, having the whole stack work on post-quantum, I think is very complicated. Maybe some specific projects that most of them, I would say, are not research focused, but maybe don't have as many applications. But big projects that aim for a lot of applications, and yeah, like most of them, they have many pieces that rely on classical cryptography, because otherwise it wouldn't scale enough or handle those many use cases. Yeah. Hope that makes sense.
I think, that makes a lot of sense. I think also from a technologist point of view, these are cool technologies, right, to explore. But there's so much research going on there that others are doing, and that we do not have the resources for to cover, that we're not going to be an innovator in this particular space, right? And we don't really have to be. Like for us, it's more important that we have something running now that is stable, that is safe for the next 5 to 10 years, that we can start getting like the product market fit I mentioned before, right? Users actually working with tokenized assets, and then we can start implementing these quantum safe algorithms as we go.
I agree, and it's not only zero knowledge, it's also the signatures, the keys, there are plenty of things, and we also want technology that is properly tested. So for now we are relying on protocols that have been out there for at least some years now, and so we'll slightly transition into those.
Yeah, we were already front runners on other technology, right? Okay, let's see. Someone asked, how much work is there for Zedger to be implemented? Well, I think you can give a quite simple answer to that one, right?
So the specification is there for most of the functionalities. There are a couple, of methods that we wanted, but we didn't have. But I would say that we have a minimum viable product, but it has not been properly tested yet. So the priorities changed a little bit, but I think it's in a stage where we can come back and keep developing. It's not a draft. It's something that is pretty solid right now. So hopefully, we will get back to that not very far away, in time.
Yeah, we'll also have to see, but I think that Hedger changed the game a bit, and also the fact that a lot of third parties are opting for ESC20 compliance, right, in terms of API. So Zedger would be there. We can do something with that for partners that don't care, but we'll have to see in how far what the implications are for that. And we can still publish everything we did there for others to use, right? So someone asked, do you see any benefits in adding MPC into our privacy stack, so multi-party computation?
Well, we do use, and we used already MPC for the generation of the toxic waste for the trusted setup for the circuits in Phoenix. I would say probably yes, if you need to build any computation where you want to distribute the trust, even for generating keys that, for example, handle the keys of the owner of a certain contract or something like this. So yeah, I see it has benefits. The only thing is, at the end, that's something that you can build on top. So you can simply have an smart contract that uses that logic. So yeah, more as an application rather than in the stack per se. I don't really see where we could use it in the foundations of our protocols. More for applications, I would say.
Yeah. Yeah, and it also depends on demand, right? I don't think we've seen a lot of demand for this multi-party computation, besides what we used it for the trusted setup, right? So I think actually with the technology stack that we currently have in place, we're covering a lot of the market that we want to address. So
yeah,
I think that's almost all the questions. There's a question about which color I like, which I'll leave out.
Yeah.
I think it's a little bit too private to cover such a question.
Okay, which color you don't like?
Nice spy. I like all of them. So even very pink. So there are some. I'll cover some other questions as well. We're still within the time. So a review of the cryptography used in Dusk, perhaps compared to other projects. Do you want to comment on that, or shine some light on that, or?
Yeah, I can comment a little bit. Well, we use cryptography in so many places. So is probably the one that uses the most amount of cryptography. But yeah, so generally we have a part from private and public key schemes, where we use elliptic curve cryptography. So you have and then we use signatures to verify that it's indeed the owner of the account that it's making the transaction. We use hash functions everywhere, for the blogs and for committing data, for anything really, for compressing information. And we use zero knowledge proofs for making sure that all computations have been performed correctly. And in the case of Hedger, we were also using homomorphic encryption, which we used to prove that if you were sending a transaction to someone, we essentially had sort of balances, and then you made sure that you ensured that what you were subtracting from your account, you were adding it to the recipient's account. And for that, we used homomorphic encryption, which is a very nice feature. So you can prove that a certain mathematical formula holds in the clear and also in the encrypted side. So you don't really need to know the plain text in order to prove that that was done correctly. The only thing is that with the homomorphic encryption that we use was for this specific use case. So you want to make sure that transactions are done correctly. Whereas general algorithms for fully homomorphic encryption, they aim for a more general goal, which is any computation can be verified homomorphically. So yeah, this is, in our case, it was like very specific and it worked out, but yeah, we didn't really aim for that like big goal. And
this, by the way, Marta, this general purpose approach is what we did with Plonk on our mainnet, right? And others are, and there's others that are trying to do this for homomorphic encryption as well.
Exactly. So for example, with the snarks, even at the beginning, snarks were like zero knowledge. There were protocols, but they were specific for certain things. Like, for example, you want to prove that you know the discrete logarithm of a certain element, or you knew the solution to specific problems. And the big revolution with the snarks is now you can write circuits that encapsulate very complicated logic. And in fact, like anything that a computer can do, you can actually write it as a circuit. So you can prove that you run the circuit, so you run that computation correctly. And the fact that you make it like so generic, that was the big revolution. And yeah, so in the case of Plonk, you can do that because you can write like generic circuits. So yeah, that's what we use. And if we compare it, for example, to other projects, many projects, instead of using the snarks, they use starks. And I've seen that they actually like combine starks with the snarks. So for example, I think they do some computations with the starks, which are better suited for, instead of writing your computations as circuits, they write it as state machines. I don't know the details, but I think it's like a different logic. So you essentially ensure that the state transitions were correct. And I think the technology of Starks works better. So, and in that case, Starks is post-quantum, but they actually don't benefit from the post-quantum, because what they do is that at the end, the proof is quite large. So they generate a snark from the Stark proof so that they can reduce the proof size, and at the end you verify in a snark. So yeah, I mean, we've seen like some evolutions there and how like the different protocols combine. And yeah, I think like every project at the end you have I mean, what is nice about these protocols that are so generic is that you can write anything you want. So it depends on how much flexibility you need. But if you have a very specific use case or a very specific circuit, maybe the protocol you are using is not the best for you, and maybe an algorithm that it's not as efficient in the general case, it may be efficient in your case. So I think in Dusk, we really try to use the protocols that were the most suitable for the stack that we had and the stack that we have. So yeah, I don't know if that answers the question, but I'm just saying, like, there are like many protocols, most of them have evolved, they have different properties, and yeah, and it really depends on what your needs, you know. So in our case, it made a lot of sense to use Plonk specifically for this, because you have like this universal setup. So if you need to write new circuits or make changes on your circuit, you don't need to change the setup, for example. The other schemes that we use, like the public and private key, the signature scheme, and the hash functions that we use, they are very well suited for circuits, which we prove in the snarks. So there are other signature algorithms, other public private key schemes, but in our case, we use it for snarks. So we need that it's well suited for circuits. So yeah, that's more or less what we have. I don't know if that answers it, or you need me to give more detail.
No, it definitely answers it. Yeah, it's quite interesting that you have these projects that say they have this quantum proof technology, right? And then they use Quad16 for verification.
Yes.
Because that's the only thing the other L2 supports, or L1, sorry. But yeah, this is what it is. Okay, thank you. I think that covers everything. I'm not sure if there were any more questions. I don't see any more that were thrown at us, but think we can wrap it up here. Unless there's something else you want to throw out there, Marta. I don't know.
No, I just want to say that it's quite a bit of a different role for me, but I'm super excited with the project, also with the team. Everyone knows a lot what they are doing, and I'm learning a lot also from the team. So I'm very excited.
Yeah, it's quite fun, and it will be really cool to see this finally come to fruition. So yeah, very good.
Yeah. Okay.
Well, thank you, everyone. Thank you, Marta, for attending and having all these questions thrown at you, putting your feet to the fire. And yeah, thank you, everyone, for participating. As always, there will be a recording of this. George will share it, and he will probably provide a summary as well, as he usually does. So thank you for that, George. And thank you, everyone. Have a good day.
Thanks, everyone. Ciao, ciao.
Ciao.